All right, so let's talk about a couple of topics about the Java programming language, and perhaps some things that might be conceptual about any programming language, not necessarily just Java. So Java declares a keyword called static, right? And we've seen that we've used static in quite a few different places. We've seen that we can declare it on a static class, we can declare it on a method, right? We can declare it on a variable. And so let's just review some of the uses of static and where would you use it, right? In one of the places that it's very common to use the keyword static is to declare it on a variable, right? Such as this, right? For instance, here we have a widget, right? That has a field variable, right? An instance variable, sometimes referred to as widget ID, and also here we have a static variable called widget ID counter, okay? And so notice that the name widget ID kind of gives it away that I am unique. I have a particular identifier. I have a unique value for every instance of the widget, right? So there would be widget 1, 2, 3. There'd be widget 2, 3, 4, widget 4, 5, 6, and whatnot. Yes, and so it makes sense that it's a instance variable, right? It will have different values for different instances. Yes, whereas static over here, widget ID counter, right? It's trying to capture things that are not specific to any one instance, right? It's trying to capture a concept that should be actually the same across all instances, right? Forever, right? Such as, well, how many widgets are there? Right? Well, it would be redundant for every widget to know that, oh, it's 3 of us. Okay? Instead, right, a better place to store it is not at any one particular instance, but store it at the class level and say, hey class, how many instances are there of you? Right? And then the class can go and count. Says, ooh, look, there's I have 4 children. Right? There's 4 instances of me. Okay? So widget ID counter allows us to store information about the class, not about any one particular instance. Make sense? So here we have a widget ID counter, and so here's just a couple examples on how we would use these variables. We're instantiating a couple, 1, 2. We're instantiating 2 widgets, each of them with different IDs, and then we are asserting and checking to see that indeed they are equal to 1, they're equal to 2, and the 3 in the widget ID counter. We declared it at the declaration of the class, right? And its value is 3. And notice the difference here on how you access those variables. If it's an instance variable, you access them through the instance. 1, 2, and then the widget ID, as opposed to the static, you access it through the name of the class, dot, and then the static variable. You can change them, both of them, unless you declare them as final. Obviously, over here, since they were not declared as final, we can still change them, right? Here, we're changing the state of the 2 instances, but here we're changing the state of the class, not any one particular instance. So that's we still access it through the name of the class. Okay. We can also declare a static on a method, right? So we can declare on a variable, right? And we can also declare it on a method as well. For instance, here we have two functions. Right? One of them is an instance method, right? That it's operating on any particular instance, the one that's instantiated, and it has access to the this keyword, right? It can access the current instance that is running in, as opposed to a static method. And a static method is defined for the class. It's not defined or accessible to any one particular instance, right? The concept of this makes no sense instead of a static method, right? Yes.
So is a static method, the whole purpose of it is just to change or
access all the static variables? Yep, exactly.
You're not actually it's not really making an instance of anything.
Right, exactly. Right, exactly. There is no instance of anything, right? And it would make no sense for it to try to access any field variables, right? Because those field variables will be just different for every single instance, right? It makes no sense for any. There's no concept of I'm accessing a field variable, but because a field variable might have hundreds of values, right, for different instances. Yes. So inside of so the compiler will catch you and says, wait a minute, you're trying to access something that is a field variable. It makes no sense. Yes.
So the static methods will be able to access the static variables, right?
Yes.
Is the purpose of if I had two different implementations of my entire class structure, or basically I had different instances of two different places, would the static method be the same for both of them?
Yeah.
Or
Yeah, but you would not call it through the instance, right? You would still call it from the class.
so even if I was, if I was trying to, if I had different instances of the widgets, and I say I had 3 here and 4 here, would it just be able to?
Yeah, only the variables that are declared static, right? Only the variables are available to you,
Okay.
right? None of the other fields would be available to you.
So it's the only way that the static method is changed is to change the static
Yeah,
variable.
exactly. Yep. Right, and indeed that's what we're doing here, right? We are modifying the static variable here. We're setting it to 0, right? Initially it was 3, right? And then we're resetting it to 0, right? We're changing it. So only a static, you only have access to the static variables in there. Yes. Yep. Yep. Well, I mean, static is kind of like the closest thing that you'll ever have in Java as a global variable, right? And so just like global variables are bad, right? That they have some side effects and whatnot. So you could run into cases where you would have that case too, right? Where you have this global variable that I can access from anywhere, right? I can set it to. So you should avoid using static access only for very specific purposes, right? For instance, one very common thing to do is to declare constants as static, right? So you would use both in tandem with static. You would also use final, right? So you give it a value, right, and it will never ever change, but it's accessible everywhere from the system. So that's an appropriate use of static together with final, right?
What about just methods, like not static variables?
What do you mean?
Like, if an utils class performs some operation
Yep.
on its inputs.
Yeah, exactly. So you would start becoming more functional programming as opposed to object-oriented programming, right? Where a lot of the decisions are going to be done in the function as you pass any arguments inside, right? And so you'll be only dependent on the state of whatever you pass in as parameters, and you would have access to anything outside of that static, right? None of the field, none of the entity instance variables would be available to you. Only to any parameters that are passed into you, right? Again, that would be similar to having a global function that is accessible from anywhere. You should avoid those kind of uses. Yep. Yes.
If you had a static variable for a simple class, does that mean that you can call it on a subclass?
Yeah, you always access it through the name of the class where it's declared on.
Okay.
Yeah, so it's
Widget was a simple class. If you had a subclass for widget, could you also do subclass dot widget ID?
no, it would be only where it's declared.
Okay.
Yep. Yes.
How similar is this to static in C?
I'm sorry.
How similar is this to static in
I
length in C?
don't remember C. I'm sorry. I did see quite a few years ago. I don't remember. I think they're pretty much the same, I would say. Yeah. Yes.
If you have a static variable inside of your class, should you not use private on it? So are you even allowed to use private?
Yeah, you can use private, right? And they would only be accessible through some public static method, right? That they could access it, and nowhere outside. Yeah. Yes.
So you can only call static fields inside of a static method.
Yep.
Can you call non-static fields inside of it as well?
From the static method, no. Yeah, it makes no sense, right? Because there could be many instances, each one with their own values, right? So it would be no way for it to say, well, which one is it, right? Yeah. Okay. static classes. A very common use for a static class is that you might declare a class that might be an inner class where you declare it static, and it could be used internally from within that parent outer class. A very common use for it is used an internal factory, that knows how to instantiate widgets, for instance, right? That the widget instantiation might be declared as private, right? Meaning that nobody can actually instantiate this widget. Nobody can call new on this widget. Right? Only a factory that is available through from outside. You can say, widget.factory, create me a widget, right? And then that factory can then create instances of that widget. It's a very common use of sometimes referred to as like the singleton design pattern, right? Where you have a single place a single instance of this thing holding around, very much like almost like a global, where you can say, well, instantiate for me a connection to a database, right? I don't know how to connect to it. I know it's listening at this port, it's listening at this URL. Go ahead and instantiate it for me based on some parameters that I might pass in, right? And at runtime, might decide to give you back an instance to a SQL or an Oracle instantiation at runtime, so that you make the constructor private, and only through the factory can you instantiate the widgets. It's a very common pattern as well, where we're declaring a static factory, right? We're declaring a static factory class, and then from outside, the only way that you can instantiate a widget would be to create an instance of the factory, and then the factory can then instantiate instances of other widgets, right? So in this case, using the factory to instantiate. So nowhere can you say new widget, right? Only through a delegated create function that internally has all the logic to instantiate. So this is what I mentioned earlier as the factory method that we saw earlier. So this would be a factory class that might have multiple create functions, right? We have multiple create functions, and depending on the arguments that you pass, right, it would know how to build different types of widgets, right? Maybe a YouTube widget, maybe an image widget, a form widget, right? And depending on all sorts of parameters that you pass in, it would know how to instantiate them, right? And go out to the database, insert, or go out to the server and decide on how is it that it would instantiate these objects for you. Typically, it would hide a lot of the decisions that you would have to make based on how is it that it would instantiate these things. And all those decisions would live inside of these create functions. Okay? Anyway, so these are fairly rare. The most common use of static that we will be seeing quite a bit throughout the course is when we use static in tandem with final, right? That we declare a variable to be not only static but also final, right? And that's the most common use of static, of just declaring constants, right? And the naming convention for declaring things constants is that they should be all capitalized, right? And if you have compound words, they should be concatenated using underscores, right? So it's a very common use where you declare these constants and then you use these constants all over the place. They're basically globals, and that's a very appropriate use of global variables, right? Actually, not variables. It's an appropriate use of global constants. Definitely avoid global variables, but feel free to use global constants. Yeah. Arrays. I'm sure you're familiar with arrays, but just real quick. Java provides the data type of the square brackets that allows you to create contiguous memory spaces that are holding the same piece of data. Yes, and the key concept there is that they're contiguous. All right, that knowing what size of memory that I need to instantiate an integer, a float, or some object, right? These memory spaces are contiguous to one another, which gives rise to a lot of optimizations that are associated with working with arrays. Yes, they allow us to randomly access any element in the array at constant time, regardless of the size of the array. We can as easily fetch the last element as easily, as fast as we can access the first element or any element in between, because of the fact that these are contiguous elements that are implemented, right? As opposed to a linked list, right? So if these were a linked list, then not necessarily would you have elements be contiguously instantiated, right? They could be anywhere in the memory space, right? So that defeats the purpose of being able to access this data structure at constant time, right? If I have to iterate over thousands of elements to get to the last element, right? My time of retrieval is proportional to the size of the collection. Yes, right. So arrays are, gives us a fixed length. It's constant time, right? We can access things very fast, right? They're mutable, meaning I can change their values, but I can't change their size, right? And they can be indexed, a constant time indexed, right? How can we use them? There's several syntactic sugar versions of instantiating them. You can say new int and then provide the right values right on there. This sets up the size of the array. Or we can use new and provide the size and would then use the default values, zeros for integers and floats, or nulls if they're objects. Or we can use this syntax and initialize them at declaration time. There's quite a bit of lots of useful functions or methods inside of the arrays library that is available through the arrays class that allows you to sort, find, manipulate collections of elements, and then perhaps convert them into higher level structures such as lists, array lists, and whatnot. Okay. A couple of new syntax that's very convenient. The variable arguments syntax. It allows you to declare functions or implement functions that take a variable number of arguments, which is oftentimes is very convenient, right? Although if you already have an array, right, it's it's just as convenient. Well, actually no, it's a little less convenient. You could have if you have a function that you don't know how many arguments you need to pass. You could just put it in an array and pass the array, yes. But oftentimes you might not have the array. Or you don't have a built array that you can just pass in. So Java provides a syntax, a syntactic sugar syntax, right, that allows you to use the ellipses, the ... notation, right, that says you can pass me any number of strings, right, just as easily pass me an array of strings. You can pass me either a comma-separated list of strings, or, right, if you want to go beyond, you just put them in an array of lists, and you pass me that instead, right? So here, set players can either take in a comma-separated set of strings. That could be any number of arguments, or it could be an array of strings, and you can pass that too. So it's a syntactic sugar syntax that makes it easier, to either pass in just an arbitrary length of comma-separated strings, or build it into an array. Yes.
Does that arbitrary length include 0?
Yes. Yeah. You get an empty array inside the function. What you get back inside of the function is just an array, right? Just as if you would pass in an array inside. Yeah. So here, new players could certainly be just an empty array of strings. Okay. So yeah, from within the function, you basically treat it just like you would treat it an array. Okay. Right, or you can pass in some array of strings. A couple of gotchas. Right, so a couple of things that we might need to just be aware of is that the arrays are not treated like primitive data types, right? So, for instance, if you compare 3 with 3, right? If you do equals, then obviously 3 is equal to 3. But if you compare arrays, right? The comparison is by reference, right? It checks to see, is it the same reference? If it is, if what you're passing me points to the same data structure, then obviously they're the same. Yes. But it doesn't do a deep comparison. So if you have two arrays that indeed have identical content, right, but are referenced by two different variables, then they're considered to be two different arrays, and and the equals would fail, right? Would say no, they're not equal, even though the content might be the same, right? So this, for instance, would fail, right? Even though you have 3, 6, and 3, 6, they're two different instances, and they're considered to be different. There are some functions that can do some deep comparisons. So, for instance, assert array equals, right, goes deeper, right? It actually iterates over the arrays, right, comparing each element with each element, right, and says, okay, well, they are equal because the content is equal, right? Now, the problem is that if the array contains pointer values, right, objects, then again, it will use the equals of each one of those data types, right? And then say, well, is this object equal to that object? And again, if it's 2 pointers are the same, then the objects are the same. If they're not, then it's not the same, even though the content might be different, might be the same, right? So if you do want to do some very deep comparisons, right, there is a deep equals, right, inside of the arrays, which will do recursive equals all the way down to the primitive data types and check to see indeed if every single field in the object is different, right, is equal. Okay. So, but this is very expensive, right? Deep equals is very, depending on your data structure, right, could be fairly expensive to recursively go down the hierarchy of objects. Okay. All right, I'm going to leave it here.